Today we are going to learn about measures of location and spread, part 1. In this video, we are going to discuss about measures of central tendency. It's the first chapter of the book Edexcel Statistics 1. Before we work out measures of central tendency, we have to work about types of data. When you get data, there are two types of data we can observe. The first type is qualitative data, which discuss about a quality, just like color, the sex, etc. The other content is the quantitative data. Here we are talking about a numerical value. For example, age, length of a leaf, height of a person, etc. Then we work about quantitative data. There are two categories we can observe. First type is discrete data. That means you can see the figures with specific values. The second type is continuous data, where you cannot obtain any boundaries between two significant figures. Let's go ahead further and try to understand this verification. Quantitative and qualitative data. Quantitative data describes a quantity. For example, age of a student in a school, the length of rod in a container, etc. The qualitative data describes about the quality. For example, the sex of a patient in a clinic, the color of a vehicle passes a bridge. Hope you have understood the difference between quantitative data and qualitative data. The other variation is in quantitative data, we are talking about numerical figures, but in qualitative data, there are no numerical figures we talk about. The next variation of the qualitative data is discrete and continuous data. When you talk about discrete data, is information which clear boundaries with two consecutive figures. For example, we know number of apples in a bag would be 1. After that, the next value is 2. There are no in-between figures. Therefore, it is a discrete data where the figures which has clear boundaries in between them. When you talk about continuous data, is the information where we cannot define a next figure between two consecutive figures. For example, mass of sugar in a bag. After 1 kilogram, what would be the next value? Somebody can say it's 2 kilogram. But don't you have any figures in between 1 kilogram and 2 kilogram? If your scale is significant enough, you can measure 1100 grams or 1001 grams, or you can work out 1000.1 grams. That depends on the accuracy. You can identify many more in between figures between two consecutive values. Therefore, you cannot define an exact boundary in continuous data. But in number of apples, after 1, there is no in-between data. You can definitely say the next count is 2. That is the difference between discrete and continuous data. Let's work out this question, try to understand much verification about discrete and continuous data. Number of candy bars in a bag. You can understand that number of candy bars. You can say that it would be 1 or 2 or 3, somewhere like that. Therefore, this is a continuous data. Then the next one, the mass of milk powder in a bag. The mass of milk powder, what you can say? The mass of milk powder, it's not discrete, it's a continuous data. So what you can say? This is discrete, this is discrete information. This is not discrete. This is what? This is continuous data. I just put ticks on discrete information and cross on continuous information. Mass of milk powder in a bag to nearest gram. Then we know that if there are 400 grams, next value is 401 grams. So simply you can say, yes, it's a, what you can say, that is a discrete information, because we know that after 400, next value would be 401, because we round off to the nearest gram, right? Number of moves in to complete a chess game. Yes, it's a discrete figure. It would be 1 or 2 or 3 or 4. Those are discrete values. Time taken to finish a past paper. What you can say? The time taken may vary. It may be like 1 hour, or sometimes 1 hour and 1 minute. Sometimes it will be 1 hour and 1 second. Therefore, this is not a discrete data. This is continuous information. Then if you come across in this case, the time taken to finish a past paper to nearest minute, yes, then what you can say? Now it turn up into a continuous information. Sorry, it turn up into a nearest minute, which should be 1 minute, 2 minute, 3 minute, 30 minutes, 35 minutes, like that. It's a discrete figure. Marks scored in an examination. This is definitely a 1 mark, 2 mark, etc. There should be, it's a discrete figure, right? Number of flow traffics occur in a junction during a month. Sorry, yeah. Then what you can say? Definitely, this is another discrete 1 or 2 or 3. So you can say like that. That is a way of identify these facts, right? Hope you can understand the difference between discrete information and continuous information, right? Let's move up to the next question. Next theory, sorry. Right. Here, we are going to discuss about certain facts when we are discussing about measures of central tendency. First one, we have to learn about the class width. Simply, we can identify in a class like this, class width would be the upper boundary minus the lower boundary. That is the class width. So you can work out over here, the class width become 5 minus 0, that is 5. Here 10 minus 5, that one also 5. 15 minus 10, that one also 5. Remember that this is a group with same class boundaries, right? Then the midpoint, how do you calculate midpoint? What you need to do is you have to get the midpoint between the upper boundary and the lower boundary. You have to add the upper boundary and lower boundary, and you have to divide by 2 to obtain the midpoint. So here, if you want to get the midpoint for this class, what you need to do? You have to add upper boundary to lower boundary and divide by 2. 5 plus 0 divided by 2. Here it's 2.5 is the midpoint, right? Here 10 plus 5 divided by 2, that is 7.5. Here 15 plus 10 divided by 2, that is 12.5. That is the midpoint over here, right? Okay, that is the way of calculating the midpoint and the class width for certain class boundaries, right? For this case, if you work out for this case, for this class, when you consider in the class width, initially you can see there is a difference. Here the class is 2 to 6 and this is 7 to 50. Therefore, you cannot identify when you are working out with this situation. You cannot keep a gap between these classes. How do you rectify this situation? What you need to do is get the upper boundary over here and lower boundary and divide by 2. 6 plus 7 divided by 2 is 6.5. Then for this case, what you can see here, the class is extended by 0.5 to this side, and that is the same concept you have to use for the lower boundary. You have to drag this one from 0.5. This from 6, you have to drag for 0.5 to this side. That is the theory of working out with the new class boundaries. Like this is the way. So if you had such bound, but you have to work out in this case, if you have a gap between this one, see the midpoint of these two. What is the midpoint of these two, or the difference between these two? It's 1. Say 7 minus 6 is 1. Then drag this one from 0.5. And this one toward this way, you can just, that is wrong. It should be from this side. What you need to do is you have to drag it from 0.5, just like this. This side. Right. From how much? 0.5. From this side 0.5 to this side. From 0.5 to this side. Then 0.5 to this side and 0.5 to this side. How to get that 0.5? You can see the gap between these two is 0.5. Or here also 0.5. Like that, so you have to get the gap over here, right? So if you drag 0.5 to this side, what could be that value? That is turned up to 6.5. If you drag 0.5 to lower side, that is 1.5, right? Then over here, if you drag 0.5 to this side, 15.5. Drag 0.5 to this side, 6.5. 28.5 and 15.5. What is the use of doing this? You can see that when you are working out with this kind of situation, you cannot keep any gap between these class. That's required, right? Therefore, this is the way of identifying this. class boundaries, right? Then the class width you have to work out not for this class but for this class boundaries. So how to get the class boundary? 6.5 minus 1.5, that is 5. 15.5 minus 6.5. 28.5 minus 15.5, that is 30, right? When you're working out the midpoint even, you can use the same thing. You can add 6.5 plus 1.5 divided by 2, 15.5 plus 6.5 divided by 2, 28.5 plus 15.5 divided by 2. But there's another point you have to understand. If you, when you're working out these midpoints, if you use this one even, you get the same answer. Don't worry with that. Only thing is that it's better to remember to use with the class boundaries, not with the class, because sometimes some confusion comes when you work out the class boundaries for certain significant figures. For class, it definitely have to use this class boundaries, but for midpoint, doesn't matter which way you use. Either you can use class boundaries or the class information, even you get the same midpoint. It doesn't make a significant difference, right? Let's move to the next theory, right? This is the most important theory we have to learn here is the measures of central tendency. What do you mean by measures of central tendency? The simple idea about measures of central tendency is a single figure which explains some information in a set. For example, if I ask, what was the mathematics marks out of students in your classroom in last term test? Different students has obtained different marks. Therefore, you can use the average mark or the mean mark to represent the mathematics mark in your class. Or you can use the mark most of the students has scored. That is a mode. Or you can use, you can what you call order the mathematics marks of all the students in order, descending order, and you can get the person who get the exactly middle. That is a median mark. So this is the measure, this is the concept about measuring the central tendency. You can use mean or average or mode or median as the measures of central tendency for a certain set of information. So simple idea that is mean, mode or median. There are several concepts we use, but in our syllabi, we learn about mean, mode and median, right? Yes. These are the ways you know that. What do you mean by mode? We know that mode is the value. We will learn much detail in next slides. Mode is the information where it most frequently observed in a set of information. For example, in a certain set, if there are more number, like suppose that number 50 is repeated more times than the other information, you can say 50 is the mode. Then what is median? We know that this concept of the median is, if you want, that is the exact middle mark out of this information. To calculate the mean, what you need to do is, we can order them in ascending order, prepare them into ascending order and see whether the mark where the exactly middle information contains. That is what the simple idea of median. We will learn a little bit later, much detail about this median, right? Mean is the most common information where we use. That is the average mark, or we have to add up all the information in the set of data and we can divide by number of information, that is mean, that is called average. We have learned this concept in our small grades, but we will go ahead with much deeper review on these measures of central tendency in this topic. Right, mean is most commonly used fact to represent the set of information, right? General concept we talk about the mean is, we call them as mean, average, expectation. All of these terms indicates about mean. The notation for mean vary. Usually we use the letter mu. This is the notation mu. We use this info notation to find a mean for a population, but there is no restriction. But generally we use this letter mu to represent mean or the average information for a population. What do you mean by population? Population means a big set of information, right? We use X bar, this notation, or the bar notation to represent the average or mean for a small set of information. For example, for a sample, if it is a population, we use the letter mu. We use X bar for a sample. That is the general standards we use, but there are no restriction to say which symbol to be used for mean. Those are general orders where we use, right? The next notation is expectation. Expectation are the concept of mean. Later on, we will learn in detail about expectation in our future topics. Right. The definition for mean is summation of information divided by number of information. That is a simple idea. This notation is, this is called summation, all the information, add all the information and divide by number of information. For example, the information are 2, 3, 3, 4 and 6. If you want to find the mean, you have to add this summation. This notation is sum. Add this information. 2 plus 3 plus 3 plus 4 plus 6 divide by number of information. How many information over here? There are 5 information. So simply you can add them together and divide by 5. You can obtain the average or mean mark for this. That's the way of calculating mean, right? For example, like this, if you have some tabulated information, like how do you calculate the mean value for that? What you need to do is, there are 15 5s. So you can add 5 plus 5 plus 5 plus 5 plus 5 plus 5 15 times. There are 10 6s. Therefore, you can add 6 plus 6 plus 6 plus 6 10 times. And there are another 10 times of 7. So you can add 7 plus 7 plus 7 plus 7 10 times. And you can add them together and divide by number of information. It's quite hard. So rather than that adding 15 5s, you can multiply 5 by 15. You can simply multiply 5 by 15, you get the sum of 15 5s. So you can do it over here. Rather than that adding 6 plus 6 plus 6 10 times, you can just multiply 6 by 10. So you obtain this answer. Rather than that adding 10 times of 7 plus 7 itself, just multiply 7 by 10, then you get this answer. If you add up all of these together, that gives you the sum of all information, right? So simply you can multiply the fact, the value, information or the class with the frequency. Then you get this fx column. You can add this fx column that gives you the sum of information divided by number of data. How many information? Some of them is that this has 3 information. This is not 3. This should be, here there are 15 information. Here there are 10 information and there are another 10. That means altogether there are 15 plus 10 plus 10, 35 information should be here. Therefore, the mean value should be 5.86. There's another concept of verifying whether our answer is correct. Usually when you are working out with this, mean comes to the set with the closer to the highest frequency. Here the highest frequency is 15. Therefore, this information would be some kind of a 5 point some kind of a figure. That's a way of understanding this question. So if you get an answer like 4 point something for this mean, that means our answer is wrong. If the answer is about 7 or something, 7 point something or 8 point something or 10 point something, that means our answer is somewhere wrong. So definitely the mean, what you call the average, would be a figure which is close to the fact with the highest frequency. It's some kind of a value over here. That's a simple idea of verifying our answer is correct. Right. Then the next important theory is combining mean, right? How do we combine mean? What you need to do is, suppose that there is a set of information. First set of information has n number of information and mean is x1 bar, right? Then there's another set that has information of n2, the mean is x2 bar. If you want to find the mean of total information, you can simply multiply this mean by the number over here and this mean by number over the second set and add them together and divide by total number of information, n1 plus n2. So simply you can understand this concept, right? For this case, the mean of a sample of 25 observation, this is n1, as 6.4, this is x bar 1, right? The mean of second sample is 30, that is, this is n2, number of information, is 7.2, this is x2 bar. Calculate the mean of all 55 observations, where the 55 came, 25 plus 30, right? Okay. Then simply to get this answer, you can multiply 25 by 6.4 plus 30 by 7.2 divide by 25 plus 30, 55. That is the answer over here. So you can obtain the answer for the combining mean. That means if you get the total mean, mean for a total set of information, right? If you work out with this example, among parallel grades in a school 9A, 9B and 9C, there are 3 classes, 45, 48 and 42 students. In 9A there are 45 students, 9B there are 48 students and there are 42 students in 9C. have sat for a mathematical test and obtained the average mark of 30. That means average of 9A is 30. Average of 9B is 25 and average of 9C is 35. Calculate the mean mark out of all students in grade 9. Right. Let's see what you need to do. So the first class there are 45, average is 30. So you can multiply 45 by 30. Right. Second class there are 48 students, average is 25. So you can multiply 48 by 25. The third class there are 42 students, average is 35. Therefore you can multiply 42 by 35. That is the sum of information. Should divide by total number of data. How many information over here? In 9A there are 45 students, 9B 48 students, and 9C 42 students. So you can add the third. Sorry, I think I made a mistake over here. This is not the answer. So you have to add up the number of information. I think it's a mistake. So we will try to do some correction over here. So this value should be how much? This is not number of information should be in 9C there are 45 students, 45 plus in other class 48 plus the other class 42, right? Then let's see what would be our final answer. Right. Let's work out and see whether what would be the answer, right? Over here, if you multiply 45 by 30 plus 48 by 25 plus 42 by 35. Yeah, 42 by 35. Yeah, 42 by 35. So altogether you get the answer 4020. That has to be divided by sum of 45 plus 48 plus 42. It is 9135. So you'll be receiving the answer as 29.77. 29.77 would be the answer. So you can say this average is a fair enough figure. So most of the information is 25. So its value is close by to some kind of a value in between this. So you can verify with this information. This answer is some kind of a correct answer. That's a way of identifying this figure. Hopefully that is correct. Yes, that's fine. Right. Okay. Then the median. This is the most important. Sorry, before we come up with this one, we have to see whether under which circumstances we use mean. We know that mean is the, if you want, you can note down this fact even. You know that when you are calculating the mean, we get involved with all of this information in a set of data. So what you need to do, you add up all of these values over here. Therefore, the advantages of using mean to mark the measures of central tendency is this mean value has an involvement of all the information in this data, right? Therefore, the involvement is 100%. Therefore, the mean value is much of a perfect solution as a measures of central tendency. Under which circumstances? But the reason is that when you calculate the mean involved, to calculate mean, you have to add all of this information in the set. Therefore, when you calculate the mean, it's involved with all of this information. Therefore, mean is a more suitable information or measures of central tendency to represent a set of data. Then under which circumstances we cannot use mean? We will learn, we have another video related to this topic. Under which circumstances we cannot use mean is if there are extraordinary figures, extraordinary large figures or extraordinary small figures available in a set of data, you cannot use mean as a measures of central tendency. This extrapolation concept, there would be another video. If you are interested on that, I will mention you the link over here. There you can see the concept of not using the figures with extrapolation figures or unexpected figures in a set of data, right? Other than that, the mean is the best information to use as a measures of central tendency. If I repeat it back, if there are extraordinary small figures or extraordinary large figures, those are called extrapolation or outliers. If there are no such outliers, we can use mean as a measures of central tendency, right? Then the median. Median is a simple concept. What we need to do is we have to categorize this information into ascending order and see whether what is the midpoint. For example, if you work out over here, you can count like this. First you can prepare them into ascending order and see whether what is the middle figure. So you can say simply the middle figure comes as 26. Therefore, 26 is the median, right? It's pretty simple. But just say next example, you can see if I first I prepare them into ascending order. After that, you count like this. It comes to, there are two figures come to the middle. There is no exact middle. In such situation, if there are two information come, we need to find out the average or the midpoint of these two middle figures, 25 and 26. Then you can add them together and divide by 2. That gives you the median for this kind of data, right? That's the concept of working out with this, right? But there is a problem. If you get a large number of information, just marking these kind of lines are quite hard. Therefore, in that case, and it makes a lot of mistakes even when you are calculating the mean. Therefore, we use a technique or a formula to calculate the median. That means if you have 100 information somewhere like this, it's kind of hard to prepare them into ascending order and to just cross like this, it will be kind of very hard, right? To avoid that, we use this technique to calculate the median, right? Okay, let's see how to do this. Simply, you can calculate the median by the formula n divided by tooth data or tooth information, where n is the number of data in a set, right? Then for this case, when you get n divided by 2, if you get an integer, just like, or a full figure, just like 5, 6, 7 or somewhere like that, in such situation, you have to add, you have to see whether what is that the information and count the next information, see whether what is the next information is and get the division of 2, just like this situation here. If you work out over here, you get 2 information. That's the situation. So when you're working out with, you see how many information? 1, 2, 3, 4, 5, 6, 7, 8. 8 divided by 2 is 4th data. Then if you get an information like 4th data, you have to count 4th data plus the 5th data divided by 2. That's the concept over here. The second consideration is when you get n divided by 2, if it's a fraction or a decimal answer, simply you can work out the next integer. For example, if you work out over here, 1, 2, 3, 4, 5, 6, 7. 7 means 7 divided by 2 is 3.5. Then if it is 3.5, not approximation, remember children, go ahead with the next value, next integer. What is the next integer to 3.5? That is 4th data. See whether what is the 4th data? 1, 2, 3, 4. So simply you can say median is 26. The same way you can count from here, right? Okay. Let's go ahead with the next example. This is the same way. There are how many information? 1, 2, 3, 4, 5, 6, 7. 7 divided by 2 is 3.5. If you get a point answer over here, go to the next integer, 4th data. See whether what is the 4th data. Remember that you have to prepare them into ascending order. 1, 2, 3, 4. 26 is the median, right? If you come across over here, how many information? 1, 2, 3, 4, 5, 6, 7, 8. 8 divided by 2 is 4th data. If you get 4th data, it's an integer. Go to the 4th data and next data. What is the next data to 4th data? That is 5th data. Then add 4th data plus 5th data divided by 2. See whether what is 4th data. 1, 2, 3, 4. 4th data is 25 plus 5th data is 26 divided by 2. So you get the answer 25.5. That's the same concept what we have used in our previous theories, even is a numerical context, right? Okay. Then if you get tabulated information, what do you call tabulated information? Information there is in ranges as well as in like the count, what do you call it? It's a tabulated data, it's in table. How do you calculate the median? There are 2 techniques if the information is tabulated data. The first technique is a graphical representation. This is called finding the median using cumulative frequency curve, or another term we call it as ogilvy. Right. Some books it mention cumulative frequency curve. Sometimes they used to mention as ogilvy. Then how do you calculate this cumulative frequency? That is the most important point. Right. Then look at this. The first concept is see whether the first frequency, count down the first frequency, 5. Is the way of cumulation. What is the idea of cumulation? Cumulation is an addition of frequencies, 5. There is nothing to add to 5, just write 5. Then add this 5 to this 19. Then what is the cumulation? Cumulation is 5 plus 19 is 24. Then at 24 to 30, that is 54. But then at 54 to 20, that is 74. At 74 to 6, that is 80. That's what you mean by the cumulative frequency. Then you have to mark this information over here, the marks or the age with this side the cumulative frequency. Then where do you have to mark this 5? Over 0 or over 10 over the midpoint. Here in this cumulative frequency shows up to 10 there are 5 information. Therefore you have to mark this 5 over the upper boundary. That is most important. Therefore we will mark 5 over the upper boundary. Remember that in cumulative frequency graph you have to mark on the upper boundary. Right. This 24 should mark over the upper boundary over here 20. Then you can mark 24 in 20. 20, 24. It's over here, right? Then where should be marked is 54 over 30. 30, 54. It's over here, right? Okay. Then 74 should mark over 40, upper boundary over here. Then 80 should mark over 50 over here. Then you can mark a smooth graph like this, right? Then how do we use this? How do you use this curve or the Ogilvy or cumulative frequency curve to find the median? You can use the same formula. Here n divided by 2 data is 80. There are 80 information altogether. Or if you add up all this, it will be 80. Because if you 5 plus 19 plus 30 plus 20 plus 6 is 80. 80 divided by 2 is 40th data. In this case, nothing to worry about the previous data what we have used. Divide by n divided by 2, those if it is an integer, the fact we can use, and if it is a fraction, that theory no need of using, you can straightforward use this the 40th data to calculate the value over here, right? Okay. Then that previous concept you have to use if you have this kind of what you call separated data only. Other than that, nothing to worry with working out with median for this kind of information, right? Then we can work out 40th data. Now in the cumulative frequency graph, go to 40 over here. Yes, here. Then go straight forward until you meet the graph. Then come down and see whether the count. So obviously it would be around, we can say it's like 25. Hopefully this is 25. It's a much fair enough figure, right? So it can go a little bit further and go ahead, it will be 25. So the median is 25. Now, can you identify any kind of a mistake when you're using this technique? You can say that when you draw this line, sometimes you might, it's a graphical representation and drawing the curve also not much perfect because we are drawing in the handmade, and these lines also kind of maybe kind of confusion. Sometimes you might not get the exact median. If you use this curve, you might get an almost close figure to median. So anyway, this is an approximated figure, but sometimes there's maybe kind of confusion, depends on the curve you draw it. It's better to understand it's better you just draw this graph according to your convenience and see where the 40th data lies at. Sometimes you might get a slightly different figure to this. That is the disadvantages of using the graphical approach to find the statistical information. So in our what do you call that theory contents, they will ask what are the disadvantages of using this kind of graphical representation. One disadvantages of using graphical representation is we cannot go for the 100% accurate information. You can go ahead with some kind of values with approximation. That is, those are the whatever the graphical representation, that disadvantage is there, right? Then this is the second example. When you're working out over here, you can you can go ahead with the 0 to 9, 9 to 19, 90 to 29, 29 to 39, that is much, and you have to calculate the cumulative frequency. How do you find it? 5 plus 25 is 30, 30 plus 30 is 60, 60 plus 10 is 70, 70 plus 5 is 75. So if we are repeating, just write 5, add this 5 to 25, that is the value over here, add this value to this much, it's over here, this one to this one, add over here, and this one to this one, you get the value over here. With that, there are totally how many information? 75. 75 divided by 2 is 37.5. You just plot the graph and find where the 37.5 data is. Yes, with that, you can work out the median over here would be somewhere like 21.5 would be the reasonable figure for that. Right. So that is how you can work out with median for this kind of information. So yeah, so that is the way of getting this value right. Hopefully, let's see whether these answers are correct. Yeah, 5 plus 25 is 30, 30 plus 30 is 60, 60 plus 10 is 70, 70 plus 5 is 75, 75 divided by 2, 75 divided by 2 is not 37.5. Yes, yeah, it's the 70, 75, 75 is 30, yeah, it's 37.5. So you can work out this figure as 21.5, but seems to be this graph has a figure. So this should be exactly 37.5. It's over here. 37.5 is, I think this graphical representation is kind of wrong over here. 37.5 should be somewhere over here. So therefore this value should be close to 25. It's like 24 or something. So 37 point, I think this graph is kind of this what you call electronically generated graph. Maybe some kind of a error may occur during that section. So it should be not should be over here. So if you work out 37.5 is a value over there. So like if you work over here, actual graph should be somewhere like this. 37.5 is a value somewhere over here, and if you just draw this and you can go a little bit down. It should be somewhere over here, seems to be. With that, if you work out, you will obtain the answer 21, 25. It's just like 24 seems to be. Let's work out and see. It seems to be 24. Just you better work out this section and see whether these answers are correct. Seems to be it's 24, right? Okay. Yes. Then, yeah. As I mentioned over here, the median, using a graphical representation for median is not much appropriate. The reason is that depends on the way you draw the graph and the way you mark on it. Sometimes there may be kind of little bit difference between the median when you are working out with median from cumulative frequency graph. From the previous example, even we can understand that concept, right? Some of the sometimes it might be kindly oscillate from the actual figures, slightly not, but it's not mainly deviated, but slight deviation maybe they are in the when you calculate the median. Therefore, we will go ahead with the method of interpolation, that is the exact way of calculating the exact median for certain data, set of data. Let's see how do you use the method of interpolation to calculate the median, right? Okay. Then if you work out over here, right? So first of all, you can mark. You can say we need to find the value for x. X is the median value. X is the median value. Then we use the category which belongs to this median. From an example, you will understand this theory and see whether in which range where the median falls into. And you can use this relationship to identify the median. In an example, we'll try to understand how to use this linear interpolation or the interpolation method to find the median. So this is the mathematical concept of finding that, right? Okay, let's go to the question and try to understand, right? If you work out over here, there are totally, first find the cumulative frequency curve. Sorry, cumulative frequency, not the curve, cumulative frequency. 5 plus 19 is 24, plus 30 is 54, plus 20 is 74, plus 6 is 8. There are 8 information. Then over here, we need to understand what do you mean by this cumulative frequency 5. This 5 indicates that first information to fifth information is in the category of 0 to 10. That's the concept over there. Then what do you mean 24 represent? That means if over here up to first 5 information over here. That means in the second category, 5th information to 24th information is in the second category. That is what you mean by this 24. What do you mean 54 represent? 24th to 54th information is in this category. What is 74 indicates? That is 54th to 74th information falls into this category. What is 80 stands for? 74 to 80th information falls into this category, right? Then if you calculate, there are 80 information. If you use the usual median formula, 80 divided by 2, 40th data. Now 40th data is in which category? It's between 24 to 54 data. You know that 40th information definitely falls in between 24 to 54, right? Then draw a line. We know that 40 falls in between 24th information to 54th information. You just mark like that. It's between here. The 40th data is in between 24 to 54. You just mark a line, and 40th information is in between 24 to 54. Mark like this, right? Okay. Then we know that that is between, that means the information of median is a value in between 20 to 30. That's the concept we have to understand. We know that 40th information is in between here to here, means definitely median is a value in between 30 to 30, 20 to 30, sorry. Then we can mark axis median is in between 20 to 30. You just mark this information on a number line somewhere like this, right? Then the concept is, you can write this short in from top side, shorter range divided by longer range. What is the shorter range? X minus 20 divided by the longer range. How to get the longer range? 30 minus 20. Shorter range divided by longer range. X minus 20 divided by 30 minus 20 is equals to, use the downwards, the same relationship with the downwards. Shorter range, 40 minus 24 divided by 54 minus 24. 40 minus 24 divided by 24 minus 54. Shorter range divided by longer range, shorter range divided by longer range. How do you write down this information? We know that a median is a 40th data. It's in between 24 to 54 data. Therefore, median falls in between 20 to 30. After that, you can use the relationship and simplify. Then you know that 20 minus 30 is 10, 40 minus 24 is 16, 54 minus 24 is 30. Then cross multiply is 10, minus 24 to other side is plus 20. It's 25.33. What was the, because the same example I have used in the first example, here you get 25. But the exact answer is 25.33. There is a slight difference between the exact answer and the approximated answer using the cumulative frequency curve. Almost similar answer is there, right? If you go into the second example, right? Over here the class boundaries are different. Therefore, you need to do the adjustments. How to do these adjustments? Here the gap is how much? Gap is 1. Then half of 1 is 0.5. Or you can divide this gap into 2 and add, drag over here 0.5 and drag over here 0.5. But when you're working out with the age cannot be a negative answer. So if you drag 0.5 to turn up to minus 0.5. For such situation, we won't mark such kind of unpredictable information for facts like age. So you can just use this one as 0. And the upper bound is 9.5. Here, if you drag over here 9.5, 19.5, 19.5, 29.5, 29.5, 39.5, 39.5 and 49.5. That is a way of identifying the class boundaries, right? Okay. Then what you need to do is use the usual format. Use the cumulative frequency. 5 plus 25 is 30, 30 plus 30 is 60, 60 plus 10 is 70, 70 plus 5 is 75. Then obtain the median. There are 75 information. 75 divided by 2 is 37.5. Yeah, 37.5. Then see where the 37.5 information falls between. You know that definitely it falls between 30 to 60. Then we can write 37.5 data is in between 30th data to 60th data, right? That means in which category? Therefore, definitely we know that median falls into this category. Sorry, you can use a class boundaries, not the this one. If there's a gap, 19.5 to 20.5. So you can just write it's in between 19.5 to 29.5, right? Shorter range, x minus 19.5 divided by longer range at top, 29.5 minus 19.5, right? Then over here, shorter range, 37.5 minus 30 is that longer range, 60 minus 30. So if you work out x minus 19 divided by 29.15 is equals to 37.5 minus 30 divided by 60 minus 30. So x minus 19.5 divided by 29.19 is 10. 37.5 minus 30 is 7.5 divided by 60 minus 30 is 30. So 7.5 minus 30 divided by 30 multiplied by 10 plus 19.5. Over here you get the answer as 22. But the answer what you obtain over here is if you use that one, This was the figure we use. Over here it's 24. 24 is a figure over here. Hopefully that is correct. Yeah. Then you can work out over here as the exact value over here is 22 is the exact median. There may be slight deviation can occur in this set of information, right? Okay, right. So that is the theory of finding median for tabulated information. But using this method of linear interpolation is the best way to identify the median. So what is the involvement of the median? You know that when you calculate the median, we have not here that median is just a middle figure. Over here we know that if you work out the median, it's just a middle figure. Only one value involved with that. Therefore, median is the what do you call that when you're working out the median? Median is having the least involvement with this data in the set. So if you work out a median, you get only a single figure. It is just a middle figure. Therefore, when you're working, if you use the median as a measure of central tendency, you have wasted all other information. Rather than that, only a single figure which is in the middle. Therefore, median is the least what you call possible measures of central tendency for a set of information. But there is a condition where we have to use median as a measure of central tendency. That is, if there are extraordinary figures, just like interpolation, extremely large figures or extremely smaller figures in a set of information, we don't have any other option. We have to go ahead with the median. That is the concept of having this median, right? Okay. So for me, if you go with the average is the best representation for measures of central tendency, because that is the what do you call that? Because it's because when you calculate the mean all the information involved with that, the least suitable measures of central tendency is the median. The reason is that median is just a simple figure, the one figure, exactly middle figure. Therefore, if you use this as measures of central tendency, we have to throw out all of the gathered information. Therefore, median is the least possible fact to identify the measures of central tendency. But if there are a lot of if there are outliers, means extraordinary large figures or extraordinary small figures, generally we go ahead with median, right? The third concept is a very simple figure, that is a mode. Mode is the information where we know most frequently observed information. That means over here you can see the most frequently observed information is 6. 6 is the repeated information, repeated 3 times. All other informations are repeated less terms than that. Therefore, the 6 is a mode, and here there is only one mode. Therefore, we call it as a unimodal set because it has only one mode. But if you come across it, is example 2. Here you have 2 modes. 3 is repeated 4 times and 6 also repeated 4 times. Therefore, this is a bimodal set. There are 2 modes we can see, right? But now you may be a little bit confused. You know that measures of central tendency is a single figure to represent the set of information. But here you get 2 information for that in and situation what to do, right? In this case, you can see 2, 3, and 5. There are 3 information, multiple mode situation. Therefore, usually we use mode for the cases of if there is a one specific figure, if you can identify one specific figure rather than that 2 or multiple situation, we use that in that situation as mode as a measures of central tendency. But in our most probable situation or day-to-day life, we cannot identify single model information because sometimes there are several information may be repeated into the highest frequency. Therefore, mode is not much appropriate. So if you want to really use this mode as a measure of centrality, you can use 2 tests. Definitely it should be a unimodal. Unimodal means that there should be one mode. And the other one is if this mode is repeated more than 40% of total information, we use mode as the measures of central tendency. Here you can see 6 is repeated or totally how many information? 1, 2, 3, 4, 5, 6, 7, 8. Out of 8, 3 information. 8 over 3 is how much? 37.5, approximately close to 40. So in this situation, we can use mode. These two are definitely not probable. The reason is that you cannot use 2 or more information as measures of central tendency because it's a because mod is a measures of central tendency is a single figure which represent the set of data. But if you consider the sequential order of using these measures of central tendency for mean, mode, and median, my advice is the best option is mean. But if there are extraordinary figures, we cannot use mean. The second option is mode, but if there are more number of modes, you cannot go ahead with mode. And the least probable situation is median. Those are the general concept of identifying the measures of central tendency. Hope you have understood. You get some kind of idea about measures of central tendency. We will use much details fact about these measures of central tendency in our the next video, where we are using more number of sums based on these measures of central tendency.